again to another episode of this tutorial platform. I am instructor Victor. Now we have another formation of differential equation here to do. Now we are asked to form a differential equation from the function y equal to a cos x plus b sine x. Now this is one of the simplest solution and one of the simplest equation we are going to encounter on this video, because this is a formation of a differential equation using a trigonometry term such as cos x and sine x. But whenever we are given a solution, a function that involves an exponential function, that one is a bit complex. I'm sure you experienced that in our former video. Now let's look at this on how we can solve it. We have here to solution. We are given y equal to a cos x plus b sine x to form a differential equation. Now don't forget one of our steps. Our step is that we are to differentiate the ordinary equation, which is the function given us here, as many as there are arbitrary constants. Now how many constants do we have here? We have two constants, which is a plus a and b are the constant that we have here, which means we have two constants. So in this particular function, I'm going to be differentiating it twice. Now for this by differentiating twice, we have our y prime, which is our first order differential equation, to be a cos x. If you differentiate cos x, you are going to be having minus sine x. So because of the constant, you have minus a sine x. And then when you differentiate sine x, you are going to be having cos x. So you have plus b cos x. Now another one, I'm going to go for another differential, because we have two constants, so I'm going to be differentiating twice. Now we now have y prime to be equal to, when you differentiate sine x, you're going to be having cos x. Now cos x multiplied by minus a, you'll be having minus a cos x. And then when you differentiate cos x here, you're going to be having minus sine x. So minus sine x multiplied by b that we have here, we'll now have minus b sine x. Now let me now educate you a little on the differentiation of this trigonometry function. If you are to differentiate cos x, you are going to be having minus sine x. Now, but if I differentiate sine x, you are going to be having cos x. So it is only differentiation of cos x that gives us minus sine x. But when I differentiate sine x, you only have cos x. So I'm sure that from that you understand what I did here. Now we now have our y prime and our y prime. Now what else are we going to do? We will look for a way to eliminate our constant or our arbitrary constants. And then for us to eliminate this, we look for a particular or the simplest solution that we can apply to remove it. All we want is to remove our arbitrary constants. Now let us look at the second differential equation and the first one. We will observe that y prime can give us minus, open a bracket, a cos x plus b sine x, because this minus now, if you multiply by what we have here, you come back to this. If you use this minus to multiply what we have here, you come back to it. I'm sure you know that, because minus times plus will give us minus. So and you are back to this particular term. So we'll factor that minus to get this. Now if you observe, look at the first function, which is y equal to a cos x plus b sine x. Now you observe that a cos x plus b sine x is the same function as y. Therefore we have that y prime is equal to minus y, and therefore y prime is equal to minus y. This is our formation of a differential equation. But then to make it look more better, you have that y prime plus y is equal to 0. So this is our formation of a differential equation using this function a cos x plus b sine x. As simple as that. Please, if you like what I have just done now, don't forget to like this video, comment, and share this video to your friends so that they can as well witness or learn from this particular tutorial platform. Thank you for watching. Bye bye.